Today we are going to study about what is meant by set of equations of Maxwell. They are called Maxwell's electromagnetic equations. In that first one is Maxwell's electromagnetic equations. One is we studied in electrostatics, which is called Gauss law. What is this? Total electric flux through an enclosure, which can be written as integral E bar dot ds bar, which will be equal to, whose answer is equal to 1 by epsilon 0 into total charge present inside the Gaussian volume. So this is the Gauss law in electrostatics. Second one, Gauss law in magnetism, means that total magnetic flux through any enclosure is equal to, can be expressed like this, integral B bar dot ds bar, but its answer is 0, which is called Gauss law in magnetism. Similarly, we studied Faraday's law of electromagnetic induction. What is that one? EMF, induced EMF in any coil, if it is linked with time varying flux, is given by minus d phi b by dt. But the induced EMF, we can express EMF according to definition. It is a work done in revolving 1 coulomb charge by the source. So EMF can be expressed like this, integral E bar dot dl bar. Then the equation will become integral E bar dot dl bar is equal to minus d phi b by dt. What is this one? Faraday's law of electromagnetic induction. So in the place of EMF, according to definition, EMF is integral E bar dot dl bar. That's why it is replaced with this. Then Faraday's law of electromagnetic induction has become like this. And fourth one, he has taken Maxwell. What is that one? Ampere's modified law. What is that? Integral B bar dot dl bar is equal to mu 0 into normal current, that is conduction current, plus displacement current, that is epsilon 0 times d phi e by dt. So these four equations Maxwell has taken, and after doing mathematical calculations, he predicted existence of electromagnetic waves, and he also calculated and finally concluded what the properties of electromagnetic waves must be. So that is why these equations are called Maxwell's electromagnetic equations. Now the properties what he identified, what should be the properties of the electromagnetic waves which he predicted. First property is what, in every electromagnetic wave there are two fields, electric field and magnetic field. So if wave is moving in x direction, say x direction, then in y direction electric field will be there. In z direction magnetic field will be there. This is a y direction, this is z direction. So in z direction magnetic field will be there. Means what? Electric field and magnetic field both will be always perpendicular, and both will travel, and that electromagnetic wave will travel in x direction. Means what? Traveling direction x, traveling direction is x. Then electric field is along y and magnetic field is along z. In that way, both fields are perpendicular to each other and they are traveling along perpendicular to themselves. That is in x direction. So in that way, two fields are there. And these two fields, this electromagnetic wave doesn't require any medium for its propagation. In vacuum also it will travel. Through any medium also it can travel. So doesn't require any medium. This is second point, second property of the electromagnetic waves. Third property, in vacuum their speed is shown with c, which is equal to light speed, whose value is 3 into 10 power 8, which will be equal to 1 by root of mu 0 into epsilon 0, where mu 0 epsilon 0 are called magnetic permeability and electrical permittivity of the free space. And so all electromagnetic waves, X-rays are electromagnetic waves, gamma rays are electromagnetic waves, microwaves are electromagnetic waves. All electromagnetic waves will travel at the same speed, which is light speed, in vacuum. And In any other medium, they will have different velocities. That velocity is given by 1 by root of mu into epsilon, where mu is the magnetic property of the medium and epsilon is the electrical property of the medium in which wave is propagating. So then wave velocity is this much. Now this can be converted into like this, c by root of mu 0 into epsilon 0. Mu r into epsilon r, like that we can convert. So next properties, there are these two fields, which are present in the electromagnetic wave. These are space varying and time varying. Means what? When they are moving in x direction, point to point, they vary periodically, sinusoidally, and at any point, time to time also, they vary periodically, sinusoidally. So such kind of space varying and time varying electric fields. So that is why they can express like this. Electric field which is existing in y direction, so Ey can be written as E0y sin omega t minus kx. Here x should be present because wave is moving in x direction. And this is called instantaneous electric field, which depends on time and space. And this is called peak or amplitude value or maximum value of the electric field. Similarly, magnetic field will be in z direction, so Bz can be written as B0z sin omega t minus kx. So in that way, both fields are space varying and time varying, both fields. And both are perpendicular again because in y direction, my electric field is and magnetic field is in z direction. Next property is the ratio of electric field to magnetic field. The ratio of electric field to magnetic field at any instant, electric field Ey to magnetic field Bz is similarly ratio of not only instantaneous fields, ratio of amplitude fields E0y to B0z amplitude values. This ratio is equal to light speed c, which is 3 into 10 power 8. So that means what? If electric field is given, you can calculate magnetic field. If magnetic field is given, you can calculate electric field, like that. Next, seventh point, they are produced by accelerating charge particles. This is charge particle which is moving with acceleration, or it is called oscillating electric charge. This is the principle to the production of electromagnetic waves. So how electromagnetic waves are produced? By the accelerating charge particle. For example, if charge is in rest, then it produces simply electric field we know. That we studied in the chapter of electrostatics. Similarly, if charge is moving with uniform speed, constant speed, that is called electric current, and a steady electric current, it is called, that produces magnetic field around itself. And if the charge is moving with acceleration, then that produces electromagnetic wave. So that is why the principle of production of electromagnetic waves is they are produced by charge particles which are having acceleration or oscillating charge particles. So next, 8th point is in any electromagnetic wave, both fields are in same phase, because just now I wrote here electric field expression, I wrote here, which having the angle which is called phase omega t minus kx. In magnetic field also the angle omega t minus kx is same. Means what? Both are in same phase. So this is the property. Both are in same phase. Means what? In both expression angle should be same phase. What does it mean? Same phase means, for example, while moving in x direction wave, at any point electric field is say 0. Because oscillating electric field, time varying electric field, so electric field at any point is say 0. Then magnetic field also will be 0. At that point, suppose electric field increases to E0y, magnetic field also increases to B0z. In that way, point-to-point variation is there. At any point, electric field and magnetic field both are varying. In same phase they vary. Means what? Whenever electric field is becoming 0, magnetic field also becomes 0. Whenever electric field increases to E0y, magnetic field also increases to B0z. And whenever electric field again becomes 0, magnetic field also becomes 0 at the same instant of time. That is how they vary in same phase. Now, 9th point is they carry energy and momentum. To prove that they carry energy, the one point will tell momentum. If imagine a metal plate, uncharged metal plate, means what on that metal plate charged particles are there. Now, if any wave, electromagnetic wave, is made to travel through that plate, then these particles are coming in motion state. So that indicates that electromagnetic wave is imparting energy to them. Means what electromagnetic wave has energy. Not only this one, radiation pressure. Around the sun, comets are revolving around the sun in elliptical orbits. Whenever comet is coming close, then because of radiation pressure, it will get tail. Means what? In the radiation pressure coming from the sun, the light is falling on the comet. Because of that light, the particles will be evaporated in that comet, and they become in outer direction, other direction. They will form one tail because of radiation pressure. So in that way, that indicates that because the tail formed because of the comet, because of the radiation is falling, that indicates electromagnetic wave has energy. And next, last point is energy is equally divided in any electromagnetic wave. Half energy is present in electric field and half energy is present in magnetic field. So these are the properties. Energy is equally divided in electric field form and magnetic field form, because in any wave there are two fields. In electric field is there, magnetic field is there. So, but the energy of the wave is equally divided. Half energy is present in electric field and half energy is present in magnetic field. Dear students, now some formulae we have to study in the chapter of electromagnetic waves. We know this is electromagnetic wave and it is falling on a surface. Suppose the electromagnetic wave has energy U. That means U energy is falling on the surface whose area is A in time delta t. So then energy falling on unit area per second, how much? That is called intensity of the wave. So intensity I of wave is given by energy by unit area by unit time. Means what? Energy is falling is here U and on area A on delta t. So intensity will be U by A into delta t. Because intensity is energy falling in unit area. Means what? U energy is falling in A area. On unit area means what? You have to divide it A. On unit time means what? You have to divide it time. That is why intensity is given by U by A into delta T. From this, U is equal to I into A into delta T. So U means what? Total energy falling in the form of wave on the surface. I means what? Intensity of the wave. A means what? Area on which it is falling. Delta T means what? Time, how long it is falling on the surface. Then there is a relation between total energy and intensity. Now, energy U, we can write mc square, because wave means what? It is not a matter. If it is matter, moving matter, energy would have half mv square. Now it is moving with light speed, then energy is mc square. Then mc into c. Then mc into c, mass into velocity, momentum. So energy is equal momentum into velocity. From this, momentum is equal u by c. That means what? Anywhere, if electromagnetic wave is moving, means what? Its momentum is given by its energy by light speed. Next, third point is, now wave is falling on the one surface, and after falling it is being absorbed. So when it is moving, before falling it has momentum p is equal to u by c. After falling, momentum has become 0. Then what is the change in momentum? Means what? Difference in final to initial or initial to final. That is a delta p, change in momentum. Means what? P minus pf. Means what? P minus this p is u by c and pf is 0. So u by c itself is the change in momentum. That is a delta p. So that means what? When wave is falling on any surface and being absorbed by the surface, that means wave has exerted the change in momentum, p is equal to u by c. So this much momentum is imparted by the wave to the surface. P is equal to u by c. Next point, then when momentum is exerted on the surface by the wave, then it is applying force, it means. So force exerted on the surface by the wave is given by change in momentum by time taken, by Newton's second law. Change in momentum, how much you got? U by c, by time taken delta t. So this is the force, expression for force acting by the any wave on the surface when the wave is absorbed. Then energy, we can write intensity into area into delta t by c into delta t. Delta t got cancelled, means I into a into c. So this is expression for the force acting by the wave on any surface when it is absorbed. So then pressure, how much it is imparting on the surface. So wave kitna pressure apply kar raha hai? Pressure is equal to force by area. So pressure P is equal to force, how much you get? IA by C. So IA by C by area. This is what I by C. So this is the expression for radiation pressure acting on any area by the electromagnetic wave, I by C, where I is called intensity, C is the light speed. Next, in any wave, there are two fields. Electric field is there. We can show Ey is equal to E0y sin omega t minus kx, because electric field and magnetic field both are time varying and space varying, and both are perpendicular. If electric field is in y direction, magnetic field is in z direction. So both are perpendicular, but both are in same phase. Already we discussed it. Now, whenever electric field is there, means what? Energy is there in the form of electric field. And wherever magnetic field is there, means what? Energy is there in the form of magnetic field. Then we studied already electric field के form में unit volume में कितना energy होगा, unit volume में कितना energy होगा. Its expression is half epsilon 0 E square. We studied this formula while capacitor is studied, energy stored in capacitor we studied half CV square. Then energy stored in unit volume we calculated. That is called energy density. So electric field के form में energy density, means what? Energy present per unit volume is half epsilon 0 E square. But here electric field is time to time varying. Then which electric field we have to take here? Then we have to convert its RMS value we have to take here. Then we get the electric field present in unit volume in the form of electric field. Energy present in unit volume in the form of electric field, half epsilon 0 E RMS square. But RMS value is a peak value by root 2. That is why then it becomes energy present per unit volume becomes epsilon 0 E naught square by 4. So this is the energy present per unit volume in the form of electric field. So means what? Electric field के form में हर unit volume में इतना energy है. Similarly, energy is present in magnetic field के form में also, because magnetic field भी है ना उसमें electromagnetic wave में. So magnetic field के form में भी energy store हुआ है. When inductors is studied, we studied this. Energy present per unit volume is B square by 2 mu 0. B square by 2 mu 0. B here, magnetic field is also time to time varying. Then in the place of B, what we should write? RMS value we should write. Because RMS value is called DC equivalent. So that is why B square RMS by 2 mu 0. So this is energy present per unit volume in the form of magnetic field. But RMS value is given by peak value by root 2, B0 by root 2. That is why then we got B0 square by 4 mu 0. Means what? This is the energy present per unit volume in the form of magnetic field, and this is energy present per unit volume in the form of electric field. So electric field के form में भी energy रहेगा, magnetic field के form में energy रहेगा. हर unit volume में इतना energy electric field के form में, इतना energy magnetic field के form में रहेगा in electromagnetic wave. Now, both the energy densities are equal, I have to prove. See, epsilon 0 E naught square by 4. This is energy present per unit volume in the form of electric field I have taken. Then epsilon 0 by 4 I wrote as such. But E naught, E naught by B naught is equal to C. This is one of the property of the electromagnetic wave. E naught by B naught is equal to C. From this, E naught is C into B naught. So that is why E naught is replaced with C into B naught. Square is there, so square. Then this becomes epsilon 0 by 4 C square B naught square. But C light speed is 1 by 1 by root mu 0 epsilon 0. We already studied. That is why C square will be 1 by mu 0 epsilon 0. That is why C square will replace with then epsilon 0 by 4 epsilon 0 by 4. C square is 1 by mu 0 epsilon 0 and B naught square. Then 1 epsilon 0 got cancelled. So B naught square by 4 B naught. Means what? We have taken energy density expression in electric field form, and we got energy density expression in magnetic field form. Means what? Both energy densities are equal. Means what? Unit volume में, हर unit volume में electric field के form में कितना energy होगा, हर unit volume में magnetic field के form में भी उतना energy रहेगा in case of electromagnetic wave. That is what we proved. After this, next. Then total energy per unit volume in electromagnetic wave कितना होगा? Electromagnetic wave में कुछ energy electric field के form में है, कुछ energy magnetic field के form में है, दो भी जोड़ना पड़ेगा. Then we get the total energy per unit volume of wave is epsilon 0 is E0 square by 4. That is the energy present per unit volume in electric field form plus energy present per unit volume for magnetic field form. But we know both are equal each other. That is why this we can replace with this. Then this become this epsilon 0 E0 square by 2. So this is the expression for energy present per unit volume in electromagnetic wave together. Or this we can express like this also, because in this total I replaced this time with this. Then total energy we can express like this also, B0 square by 2 mu naught. See, in that way, when electromagnetic wave is passing per every unit volume, total energy is epsilon 0 E0 square by 2 or B0 square by 2 mu naught. Both are same. So per every unit volume, this much energy is present in electromagnetic wave.